This is problem number 2 from section 2.1. In this problem it says, find the average rate of change of the function over the given intervals. And they give you h of t is cotangent t. And they have interval from 5 pi over 4 to 7 pi over 4, and another interval from pi over 3 to pi over 2. Remember, these are x values or input values. So the first thing we need to do is we need to find the output values for each function. So let's start by saying, we'll say h of 5 pi over 4 equals cotangent of 5 pi over 4. And remember that cotangent is cosine over sine. It's the inverse of tangent. And tangent we know is sine over cosine, so cotangent is cosine over sine. If we bring out the unit circle, we look at 5 pi over 4. 5 pi over 4 is down here in the bottom. We get negative root 2 and negative root 2. So they're both negative, so quadrant 3. So if I divide those, right, I get negative root 2 over 2 over negative root 2 over 2. Well, that's the same thing, so I end up with 1 for my output there. So my coordinate is 5 pi over 4, comma 1. Let's do the same thing now for 7 pi over 4. So I end up with cotangent 7 pi over 4, which is equal to cosine 7 pi over 4 over sine of 7 pi over 4. And cosine 7 pi over 4, let's look at 7 pi over 4. That's root 2 over 2 comma negative root 2 over 2. So the sign is negative, so we're going to go ahead and write this is negative root 2 over 2. This is positive root 2 over 2. And so we end up with, this would be, they're essentially canceling themselves out, but it's a negative, so it's negative 1. So my coordinate here is 7 pi over 4, comma negative 1. Now I need to find the slope, so I'm going to say m equals, we're going to take negative 1 minus 1 over 7 pi over 4 minus 5 pi over 4. This is negative 2 over, this will give you 2 pi over 4. When I flip and multiply, that's negative 2 over 1 times 4 over 2 pi. The 2's cancel, I'm left with negative 4 over pi for my slope. Now we're going to do the part B, so that's part A. Gotta mark that here. We're going to do part B, and let's do part B with a different color. So we're going to go h of pi over 3. H of pi over 3 is going to be cotangent pi over 3, which equals cosine pi over 3 over sine pi over 3. So we go to pi over 3 on our unit circle. Pi over 3 is here. So it's root 3 over 2 and 1/2, right? This is sine, this is cosine. So we're going to have cosine as 1/2 over root 3 over 2. When we flip and multiply, we get 1/2 times 2 over root 3. The 2's cancel, and I'm left with 1 over root 3. So my coordinate there is going to be, let's see, the coordinate there will be pi over 3, comma, 1 over root 3. And now we'll go to the next part, which is h of pi over 2. And that gives you cotangent pi over 2, which equals cosine of pi over 2 over sine pi over 2. Well, if we go to pi over 2, we can see that pi over 2 is 0, 1, right? Cosine 0 and sine is 1. So cosine 0 over sine 1 gives you 0 for that spot there. So our coordinate is pi over 2, comma 0. Now let's go ahead and subtract those to find the slope. So we're going to say the slope is 0 minus 1 over root 3 over, and we end up with pi over 2 minus pi over 3. When we subtract on top, we get negative 1 over root 3 over pi over 2 minus pi over 3. Pi over 2 minus pi over 3 is going to give you, this will give you 3 pi over 6 minus 2 pi over 6, which is going to give you negative 1 over root 3 over a single pi over 6. We're going to flip and multiply, so it's negative 1 over root 3 times 6 over pi, and we get negative 6 over pi root 3. Now we could probably rationalize that. If we do rationalize that, we're going to multiply by root 3 over root 3. And so we end up with the root 3's. We'll end up with, on top, we'll get negative 6 root 3 over, this will give you just 3 pi on the bottom, which then will reduce to negative 2 root 3 over pi. So the rationalizing kind of makes it look a little bit better because negative 6 over pi root 3 didn't look so nice.